Hi, everybody. I'm Jay Wetter. We're going to start in about a minute. So in the meantime, because this is a Canola Watch webinar series, just a quick reminder that if you don't know what Canola Watch is, you can go to canolawatch.org, O-R-G. You can sign up to receive the regular emails. The other thing I do is Canola Digest magazine, which is busy this time of year. And all of those articles are online at canoladigest.ca. So we'll start in about a minute. Okay, here we go. Welcome to the first episode in our Canola Watch 2021-22 webinar series. My name is Jay Wetter, and I'm your host, and I'm working on behalf of the 4 host organizations who are the Canola Council of Canada, Manitoba Canola Growers, Sask Canola, and Alberta Canola. And we're glad you're here, and we hope you can join us for all 6 of these monthly winter webinars. The topic today is genetics, environment, and management, finding room for improvement. What drives yield can be divided into these 3 pillars: genetics, environment, and management, which is shortened to G by E by M. Many different factors and interactions occur within and among these, and because each farm across the prairies is unique, there is rarely a broad, sweeping solution or system that will work for all. The point of this webinar is to give growers and agronomists a few ideas so they can begin to scratch the surface on G by E by M and find the best interaction for each farm. We have 3 presenters, Paul Bullock, Nate Ort, and Keith Fournier. Then we'll have a Q&A. We want your questions, so please use the Q&A feature below to pose a question. You can also chat with us and with other participants using the chat feature. If you put a question in the chat, there's a chance we won't find it. So if you accidentally put it in the chat, just cut and paste it into the Q&A. Also note that attendees can get a CCA credit, and we will provide the code later in the event. Okay, we're ready. We're going to start with Paul. Paul Bullock is a professor and former head of the Department of Soil Science at the University of Manitoba. Formerly, he was a global crop forecaster with the Canadian Wheat Board and a crop application specialist with Noetics Research, Inc. His research in agrometeorology includes crop modeling, crop risk assessment, and soil moisture assessment methods. Here's Paul.
Hello, I guess I'm ready to go here, am I? So I'm going to share my screen. Put it in presentation mode, hopefully. And Jay, if you can just let me know if everything's coming through.
You're ready to go, Paul.
Okay, thank you very much. Welcome, everyone. Great to be here to share a bit of information about the prairie growing season weather in 2021. So this is the environment side of that trifecta that Jay just introduced to you. And as I used to have to say back in the Wheat Board days when we were doing these kind of briefings, that I'm just the messenger, even though it may not sound all that great. That's what I'm doing, is just telling you like it is. So, okay. So growing season weather in 2021. So any of you that follow some of the information that's provided by Les Henry will know that when we think about a growing season, we have to go back to the previous fall. And Les Henry, for several decades, has been the person who has put together a snapshot of what fall soil moisture conditions are across Western Canada. And this is what he provided last November, a year ago. And what you can see from this, what the takeaway is very simple. The majority of Western Canada going into the winter of 2020 was dry or very dry. There were some exceptions, but the majority of the area was dry. So that's kind of where we started things. Everything goes into a deep freeze, and then along comes the spring, and we start to do our cropping. So the way it shaped up was kind of like this. May came along, and it was definitely cooler than normal, somewhere on average for the month, a couple of degrees. And this was general across the prairies, with the exception of maybe the Peace River region. So basically what we saw to the beginning of 2021 was a cold and dry soil for spring planting, definitely not ideal for germination. And there were issues with flea beetles because the flea beetle control not being as effective, and some very thin canola fields. Just to make sure that things were a little bit uncomfortable, we ended up with a frost late in May. This is a map that's showing the lowest temperature recorded during that last week in May. And if you look closely, there's areas like all of Manitoba and a large area in Saskatchewan experienced either a light to a somewhat heavy frost during that time period. So it ended up, there was reseeding that was taking place because of it. Rainfall in May was quite variable. To characterize it, it really depended where it is you're farming, because we had areas in Manitoba and in the Peace River region that were quite low for precipitation. This is a map showing the percentage of the average precipitation for the month. And then we had areas through the central part of Saskatchewan and Alberta that were near normal, and even some areas that were above normal. So it was highly variable. When we get into June, things changed. First of all, the temperature was no longer below normal, it was above normal. So we're looking at anywhere from 2 to 3 degrees for above normal for that across the whole month. So that was a turnaround for what was happening in May. The precipitation side was still variable, but I would say was drier in tone than it was in May. We have areas there that were quite below percent of average. Some areas were a little bit better, but in general, I would say that June became a bit warmer and a little bit drier. And it was enough that if you have a look at what the Canadian Drought Monitor was saying at the end of June, already was talking about some pretty extreme drought in Manitoba, some areas of Saskatchewan, and fairly widespread dry conditions. So that was already apparent by the end of June. So that wasn't particularly encouraging at that point of the growing season. July really didn't help much. That average temperature that we're showing here, it continued to be anywhere from 2 to 3 up to 3 to 4 degrees above normal for the whole month. And it wasn't just that it was above average. In fact, really what it was some of the extremes. So this is a map. It's showing the highest temperature recorded about the third week of July. And what we're seeing here is that a lot of those temperatures, like the highest temperature recorded, were well above 30 degrees. And it wasn't just 1 or 2 days like that. July, if you look at, this is another map, but it's showing the number of days with a temperature above 30 degrees. This was recorded from the period from April 1st to July 31st. And many of these areas we're looking at, a couple of weeks with temperatures exceeding 30 degrees. Definitely very unfavorable during the period for canola flowering. So this just really was not very good for the crop at all. The precipitation was even worse. percent of average precipitation. You can see widespread areas, less than 40% of normal. The taps really got turned off just about everywhere. So if you go and have a look at the Canadian Drought Monitor and what was it saying as of the end of July, well, kind of what you would expect. That drought that was showing up in June just became that much worse. So, by this stage, this was very severe. If you look at satellite imagery, the vegetation index that was reported, this is again around the third week in July. This is a time period when you expect most of the major crops in Western Canada to be near the peak of their vegetation development. And what's being shown here is how does that compare to the normal. And you can see there's large swaths across Western Canada where that vegetation index was much lower than normal or lower. Some areas were doing a bit better, but basically this is mirroring what we would expect based on the drought conditions. The vegetation itself was not looking particularly favorable. So at the end of the growing season, this is 90 days, so it's roughly the August, September, October time period. We did see somewhere around the middle of August, places in the eastern part of Saskatchewan and into Manitoba that started to receive rainfall. Some of it much above normal rainfall, but that was far too late to be much help to any of the canola crops by that point in time. It did help with forages. It did help some of the late and longer growing season crops, but it didn't do anything for canola. So this is now in what will be helping to set up what we might expect for fall soil moisture for next year's growing season. And you can see that those drier conditions through Western Saskatchewan and then into Alberta, they do not bode well for 2022. It can change between now and then, but it's certainly not starting off wonderfully. So the latest information that I could find from Statistics Canada was what was reported in September for provincial canola yield estimates. This estimate is based on weather and satellite imagery. And you can see that 2021 was significantly below the previous 4 years. Even in some of those years were somewhat dry, but 2021, you can see how exceptional it was. If there's any surprise on this chart, it's the fact that that yield estimate for canola in Manitoba was as good as it was, considering how severe the drought actually was in 2021. So, like I say, don't shoot the messenger. This is, was definitely not a great growing season for canola yield. In terms of being able to improve, well, I mean, hopefully, we've kind of set a low expectation here, and just about anything would be better than what we saw in 2021. And I'll leave it there.
Great, thanks, Paul. We had a little bit of laggy audio there, Paul, and it might have been because we had your video on. So Nate and Keith, if you think you might have bandwidth issues, it may be better just to run your presentation and not your video, just to see if that helps with the audio quality. All right, we're moving on to Nate. So Nate, you can get yours loaded. All right, Nate Ort is an agronomy specialist and crop physiologist with the Canola Council of Canada. And in 2021, Nate completed a Master's of Science in Plant Science at the University of Manitoba. Nate and I worked together, and it's pretty clear in working with him that he's passionate about using science and research findings to promote best management practices and to explore research, creativity, and innovation to tackle agricultural challenges. Here's Nate.
Hey, hey, thanks, Jay. I'm assuming that you can see my screen okay?
Yep, looks good, Nate. And
Great.
your audio is good so far, so you can keep your video on.
Oh, okay, cool. You all get to look at me as well. Okay, so my segment of today's webinar is looking at tracking canola phenology, genetics, environment, and management, finding room for improvement. So what is phenology? Phenology is the study of life cycle events or growth stage timing, and the external influences, either biotic or abiotic, that might affect this. So, as you can imagine, in the spring, we plant, and then it comes out of the ground. But what really is driving this rate of growth and development? And from seed to emergence, this is mostly soil temperature, soil moisture, but there could be some management practices in there as well that also affect this. And progressing through the life cycle of canola from emergence to let's say flowering, the example on the screen, what else drives, what can drive phenology then? So we have air temperature, soil temperature, precipitation, or the amount of available soil moisture, but also things like photoperiod, the length of day, or the amount of solar radiation. And these, of course, all interact with each other. And so it's just incredibly complex. But to further, even to add on to this, different factors affect the rate of growth and development differently. And it depends on the growth stage that it's in too. So this kind of goes for most crop species, but the optimal temperatures for max growth rate and development is usually warmer when the plant is in the vegetative stage and lower when the plant is developing reproductively. So as you can imagine, when I was younger, I preferred warmer temperatures. And now that I'm a little bit older, and mostly because of my current hairstyle, I prefer cooler temperatures, because these cooler temperatures mean that there is either less sun or I'm in the shade and I'm not going to burn my head. Or I can wear a hat, but I don't often think of that. So phenology, back to G by E by M, which drives yield, but which drives yield the most? Do they impact production the same consistently, or is it different? The genetics that are commercially available now are good. There are good hybrids available. And management is good too. We're good at our jobs. Farmers are good at their jobs. Agronomists are good at their jobs. We do research all the time to try to improve this. And I think genetics and management, we do a really good job of. In my opinion, environment drives yield the most. And I think that 2021 growing season is a really good example of this. You can have the best genetics, you can do everything right management wise, but if it doesn't rain. So I'm going to be talking a lot about environment too, and kind of an exercise that Canola Council agronomy specialists participated in this year. So I'm going to be talking about tracking phenology and how you might be able to make this work for you, and how we can maybe find rooms for improvement just by looking at growth stages and when these occurred. So in 2021, Canola Council agronomy specialists recorded growth stages for the same hybrid through the growing season. So here's, the sheet here. We just went out to the field at least once a week, and you'd write down the calendar date of all these stages. The environmental conditions and the management practices, of course, varied. These were approximately where the fields are, right? So I've been calling this the CP&I, or the agronomy specialist farm, but that's a big farm, right? It's Western Canada, and most farms don't farm in all three provinces, but so, keep that in mind. But this exercise, it was a good way to, summarize the growing season. So again, yeah, of course, environment was different. These two charts that I have, the one on top, that's accumulated growing degree days starting on May 1st and ending at the end of September. You can see, if you're looking closely, we're not going to get too far into this, but the purple line and the green line, those are Manitoba. They accumulated the most, and so on and so forth. And below it is precipitation or rain for the same interval. And what I didn't show here is actually all of these locations compared to their climate normal. So, the normal growing conditions for a given location based on a 30-year average. For heat, all locations were above normal. So it was hotter than normal. For precipitation, all locations were lower than normal. So it was hot and dry. I think we all knew that already. Diving into the results. So from planting to emergence, and if you see this figure here on your right, if you imagine planting at the start of this bar and emergence at the end of the bar, a timeline of sorts, if you will, and the value in the middle, that's the number of days, right? So why, obviously some of these fields emerged a little bit quicker than others. This one here, that was my field, took 2 weeks. And why could this be? And so, you know, when you have these data, you can start looking for trends. And again, this is looking at the, you know, environment drove all of these differences. But imagine if, you know, you decide, I'm going to plant later this year. How did that affect time to emergence? Or I'm going to grow a different variety, or I'm going to seed lighter or heavier, or maybe you have an on-farm trial and you have a bunch of different comparisons that you need to make. Tracking phenology can really provide a lot of useful data. One thing I noticed with our data set was these fields that emerged quicker were all planted after May 15th, a trend. Another trend that I noticed was the average temperature 10 days before seeding. As this increased, the days to emergence decreased. So in this case, planting in warmer later spring, this hastened the time from planting to emergence. Of course, planting later isn't always possible. You know, we have more than one crop to plant. We have a lot of ground to cover in a relatively short window of time. But, you know, increasing that time from planting to emergence, this can have a lot of benefits. And this can lead to uniformity in the plant stand. Things like insecticide seed treatments, you know, these don't last forever. So let's get the plant up and out of the ground as quickly as possible. What about early season growth? So I have days from planting here and the vegetative development emergence, you know, cotyledon through to bolting. And you can see that this was different among the fields that we observed. It would be great if this line was actually more flat, because that would mean that canola just raced through those growth stages. And that's important for flea beetles as well too, right? Like if we can outgrow it, great. And when I looked at the average number of days and stage among these fields, you know, there were some that were quicker. This one in Saskatchewan was growing faster, and same with Alberta. And again, this will be largely due to environment. But, you know, if you can imagine, say these are all different hybrids on your farm, say it's a side-by-side trial, why are some doing more than others? How do we increase early season growth rate? Can we do this through selecting hybrids? Do we plant earlier or later? Seeding rate, pest management? What about fertilizer placement? A pop-up phosphorus effect with when you put you know, seed-placed fertilizer, seed-placed phosphorus. It's a tongue twister for a plant scientist. What about phenology? Flowering. So the duration of flowering, we always hear more time in flower can mean greater yield, and that was actually observed in the fields that we looked at this summer. So, you know, as the duration of flowering increased, so did yield. So how do we get canola to flower for longer? Do we plant earlier? We try to shift that, you know, window into maybe cooler temperatures. Would that help? Do we plant later? Does this have to do with hybrids? What about seeding rates? It's, you know what, you're going to end up, I'm going to have more questions than answers. I'm more of a question guy. I don't really have a lot of answers. So flowering, heat stress, widespread across the prairies this year. You know, temperatures above 30 degrees during flowering, this can lead to yield loss. And so what I looked at in this data set was a percent of flowering days above 30 degrees. So imagine, you know, your canola crop flowered for 20 days, 10 of those days were above 30 degrees. That means that 50% of the flowering days were pretty hot, and that sucks. So what does that mean? In this data set, what I noticed was when this percent of flowering days was greater, days in flower was shorter. So high temperatures during flowering can lead to a shorter flowering duration. And these, of course, the shorter flowering duration and also the heat stress will lead to reduced yield. So which hybrids on your farm flower the longest? I think this is a good and an important data to collect for hybrid comparison trials. If you have, you know, 2 or 3 or however many you choose to compare, tracking when flowering starts. And actually these heat stress, most experiments, they consider flowering from bolting. So, you know, even actually before there's visible flowers, but bolting to the end of flower. And which are the first ones to flower, and why is this? Moving forward to pod and seed development, something that that I noticed in these fields was when days from bolting to 60% seed color change, the recommended timing for swathing. When this increased, so did yield. You know, so do some hybrids spend more time in reproductive development than others? And you know, this is something that life science companies and canola breeders are probably selecting for already. But you know, I would encourage you to look at this on your farm, and maybe you'll notice differences among your hybrids or management practices or whatever. When you look at, you know, the big picture of what happened for us in the fields that we observed, this is kind of the timeline. So planting, emergence, flowering starts here, or bolting, end of flowering, and then, you know, reproductive development. And this is what it looks like over the growing season. And it gives you a snapshot of, you know, look, this field was planted later and it matured later. Well, that makes sense. But this field here was planted, well, it wasn't the first one planted, but it wasn't the last, and it was actually the second last to mature. So, you know, when you start recording these things, you can look back and look at the environmental conditions maybe during that time or what have you. You know, and so you can do this too. This form is actually on our website at this link here at the bottom of the page. Scroll all the way down to the bottom. And I think it's a really good tool that you can use to evaluate genetics or management, and genetics by management. Of course, there will be interactions between those two. Things like hybrid selection, so maturity or early season vigor or growth rate, maybe the duration of flowering. What about a fertilizer experiment? You know, the starter pea and early season vigor, are those plants popping up out of the ground? You know, record this data. I always cringe whenever I see early season vigor data as a scale. I want to see this. When did these stages occur? You know, how big is the plant? Pull out the plant, weigh it, measure it. Don't give me a rating. What about planting conditions? Do you go later? Do you go earlier? That you can do that for this too. You know, and so, like I said before, probably more questions in this presentation than answers. But you know, I think that's one of the best parts about my job is I get to ask a lot of questions. Thanks, Jay.
Right on. Thanks, Nate. So yeah, maybe not so many answers, but by asking questions or asking the right questions, and the farmer and the agronomist can start to form, you know, if not a perfect answer, then at least you know, a management strategy that increases the probability of success, which is kind of the key to agronomy. It's not this will work. It's more like this will increase your probability of success. We don't have any questions yet in the Q&A. We're not going to that yet. We're going to Keith first, but make sure to put your questions in the Q&A so that I can ask them of our guests when that session starts. If you think you have answers, use the chat and share them with us. But in the meantime, we'll get on to Keith. All right, so Keith Fournier farms at Lone Rock, Saskatchewan, which is right near the Alberta border, not far from Lloydminster. He's also director with SaskCanola. And Keith has been a great source of information for me over the years with articles and whatnot. And he's always willing to join conversations and host tours, because he believes that through sharing experiences, we all get a little smarter. Like I said, I've interviewed Keith a few times for Canola Digest articles and probably some other stuff as well. Here's Keith.
Thanks, Jay. So I will, Justine's controlling my my slides here, so I'll get you to advance to the next one. So is my video okay, Jay? Is there any lag in it?
No, so far so good, Keith. Yep.
Okay, that sounds good. So where I farm at is called Lone Rock, and so this like sometimes things just don't seem like they're labeled quite right, and so Lone Rock, you know, you'd think one rock, and so this here was a day that my brother-in-law, he said, you know, there's a few rocks out in the field there. Well, he didn't even say a few. He said there's 3 or 4 rocks out in the field. He says you won't need anything else. Just run around and get them with your pickup. And so this is the end result. And so sometimes, you know, you're a little bit deceiving when I would imagine when my grandfather moved to Lone Rock, he was probably thinking one rock. And you can see right here, I mean, we just end up with a pickup of them after we finish seeding. So I'll get you to move to the next one, please, Justine. So Paul and Nate had talked about, the environment and a lot of how plants respond to the environment. And so, but for the most part, environment is out of the control of our hands as farmers here. And so we have to deal with the, I guess, manage that environment just with what we've got to use on our own farms. And so, I mean, that varies vastly across Western Canada. I mean, you look at areas from like Swift Current, Lethbridge, up into the Peace River. And I mean, I'm from Saskatchewan, so, I often think of Meadow Lake down to, south of Regina or into that Swift Current area. Manitoba, you've got like Russell down to Winkler. The rainfall amounts you get vary vastly. Your growing season varies vastly. And so the management practices do vary a lot across Western Canada, but there's a lot of other factors that come in. I mean, I'd mentioned the growing season, but there's also what might be a right variety for you, whether it's not the right one for someone who's, a province or two over, but maybe it's not even the right variety for your neighbor that's 2 or 3 miles down the road, because our management practices vary vastly too within our farm. I just, think of equipment. I mean, some of us are set up for straight cut, and maybe the next person down the road isn't. We all have different combine capacities. Like I might have a combine that I think, okay, well, I'll combine 1,800 acres with that combine. I might have a neighbor that's thinking, well, he can get 3,500 acres out of his combine. And so that's a whole different management. And when it comes to canola varieties, the choice in that will probably vary too with that management, with your equipment, with your capacity. I mean, you might even have a dryer on your farm when you talk to about equipment, and a neighbor doesn't have. Herbicide systems, like rotation, quite often will dictate herbicide systems we've got. So I know up in our area, our options for rotation aren't nearly where they would be down in, say, southern Manitoba. And so lots of times they will want to use, like the Clearfield canolas are much more prevalent in Manitoba, especially the southern part, is because because of rotation, they're having to fit the canola into rotation. Whereas up in like northern Saskatchewan, a lot of Alberta, the Clearfield maybe isn't as prevalent just because of we don't have that option. This year, another one coming up is variety availability. I mean, usually you think that you've got a variety that you just go out and you pick your variety, but this year that's another wrench that got thrown into the works. Was you might have your variety picked out, but maybe that wasn't available and we have to go down to the second or third one. And also we all have different variants of risk as farmers. So yesterday I went over got onto the internet and I was checking out the number of varieties that were available. And, there might be more, but I come up with 8 seed companies, and that's if you put Corteva and Brevant into, Pioneer Seeds and Brevant in under Corteva, that we have 8 seed companies, and I counted up 86 different varieties. When I first started farming, there was a choice of you had a Polish or an Argentine. So the Polish, okay, so we went and cleaned up, some Tobin seed, and the Argentine, well, you could go to a Westar. And so now, we've got 86 varieties, and great that we've got some companies that are cranking out some really good genetics because of that wide variance that I had talked about, environmental conditions and growing season. There's within the 86 varieties, there's 4 different herbicide systems that we can use to be able to match into our rotations and use for weed control, depending on the weeds we've got. So, we've got some wonderful options out there. But there is a lot of things that make that variety choice really difficult when you're looking at is how, how do you compare the apples to apples? And like each seed company, they compare yields to different checks. There could be different scale ratings for standability and pod integrity. And so sometimes, that it's what might seem as a simple decision becomes a very difficult one. And with Canola Council is, I believe, will be releasing a pod integrity rating. So companies will be rating a pod integrity, and hopefully that will be one thing that will be standardized for this coming year and take some of the confusion out of it. But for this year, for choosing a variety, yeah, there are the different standards and ratings for that pod integrity. Next slide, please, Justine. So because of, I guess, a lot of choices and maybe some confusion out there, in 2011, the 3 prairie canola commissions were encouraged to start up canola performance trials. And this was to be able to just give the farmers one more tool to be able to compare their yield, the maturity, the standability, all to the same check, because different companies are using different checks. And so again, that makes it hard to compare those apples to oranges. So the canola performance trials, I'm going to call them CPTs for short here, it is one more tool that you could use to be able to go back and just verify that variety you picked is just have that confidence that maybe it's the one you do want. So this year we had 31 varieties in the CPTs across the 3 provinces and across the 3 growing zones. And they were divided into street cut and swath. There's a protocol for being able to put these in, because we want any data that we get off of here, if farmers are going to be able to use it, it has to be of a high quality and it has to be trusted by the farmers. But it doesn't only just have to be trusted by the farmers, it has to be trusted by the seed companies that are putting those varieties in. Because if we're not, with the CPDs, if it's not producing good data that can be trusted, they're not going to want to have their varieties involved within the trials, just because it just might be misleading on the way out. So yeah, data being high quality and trusted is number one. So we do have a technical committee which designs the protocols. And within that, we draw expertise from the provincial oilseed specialists from each province. There is a farmer rep from each province that's on there. And the seed companies, pretty near every seed company has a representative that's on the technical committee, so that they could feel confident that the protocols that are used on canola performance trials are going to show their varieties in a fair way. So the reason I wanted to cover on the 31 varieties this year. So the map that Paul had showed out and looked at you can see there's wide areas of drought. And out of those, the 31 varieties are still in there, but the number of sites that we have for the CPTs across the prairie provinces, we lost about 50% of those. And so we're restricted some in the data that we're able to provide this year. But that same holds true. I mean, the CPTs were restricting the data, but we're no different than any other seed company that's providing data for their varieties. They also had probably 50% loss in their plots too. So that was just one factor that came, that was right across Western Canada. Maybe not so much Manitoba, but Saskatchewan and Alberta had some difficult conditions this year. So the CPT results are printed in the Western Producer insert that comes out every fall. And also each province provides a provincial seed guide. So if you look in there under the canola seed varieties, and that information that you see there all comes out of the canola performance trial data that's generated. But there's also the ability to be able to go to the Canola Performance Trials website, and it's up on the screen there. And so this is what the website looks like. And so it's searchable, that you can choose at the bottom, you'll see where you could choose your province. You could choose your growing zone type you've got. You could choose your trial type. There's, so I had talked about the small plots, but there's also field scale trials. So BASF provides their data on all their field scale trials for their varieties that they do across Western Canada. So that will be the trial type will be the field scale trials. But then for the small plot, you can search for the straight cut varieties, and you could also search for the swath varieties. And then at the bottom, you could choose your year that you want to search for. So let's say that you want to pick out a variety, or you want to use 2 or 3 years. I see on there 2021 wasn't available here the other day to be checked, but if it isn't there today, it should be there within the next week or so, that you'll be able to view that. But you could choose the year you want to check. And for a year like 2021, it might be a great idea to go onto this site and check 2021 plus 2020 or 2019. And you could go over 2 or 3 years, because maybe the data, because we had some environmental conditions which just weren't natural. And so you can choose over, say, 2 or 3 different years. You could choose over different growing zones if you want to see, what would happen if you're in a different risk zone, and just query for the variety you think might be best chosen for your farm. So this maybe isn't what you want. You could use this to choose your own variety, but lots of times you could just use it to go on and verify your decision, just to see if, it was the right one, or maybe there's another option we could use. So that's the information that another option we could use for growers to be able to do some variety checks, to be able to that would best suit our farm and our management. So that wraps it up, Jay. Yeah, thanks.
Right on. Thanks, Keith. So we'll get into the Q&A now. And Justine or Cass, I'm not sure when you wanted to post the CCA code, but if you want to do that now while we're thinking of it, you could, or we'll just make sure to save it to the end. Hey, Keith, I want to go right into you first with a question. We've got a few coming in, but this one's from me. So, with those 8 different seed brands and 86 different hybrids, what's the most important factor or feature for you when you're choosing the right cultivar for your farm, or cultivars?
Yeah, for the first thing I would look at would be choosing a herbicide system. Because quite often, Clearfield, we've got pulses into our rotation. So for my farm, I find that the Clearfield doesn't really have a great fit, because we want to be able to use that Clearfield herbicide system for controlling weeds in our pulses. So I would end up, looking for a Liberty or Roundup system, number one. And I do rotate every couple of years. I'll rotate from one to the other. And so that would be the first one that I would look at. Then after that, I would match it up to my risk. Like for my area, I would say, I might be able to get a little bit more yield out of having a longer growing seed, out of having a longer maturity variety. But do I want to accept that risk on my farm? We've had, like this past year, we had with the extra heat units, we were really great, but we've had some years that we're really pushed and we're out there waiting for the snow to melt so we can get back out. And so I always take and I like to make sure I'm not too high on the risk. So that's going to vary from one farm in one area, this Western Canada, to another. That's what I use on my farm.
Okay, so Nate, I'm gonna build on that and go to you. So the CPT trials that Keith talked about, we know the days to maturity for each cultivar in the trials. But what you're saying is that almost, well, not more important, but, is that period up until first flower. So if you've got a shorter period to first flower and longer flowering, you're more likely to yield more. So can we track? I don't think CPT does this yet, but is it fairly easy for a farmer to find out information on days to first flower?
For canola, not really, no. But so days to first flower, it can sometimes be related to maturity. So those earlier maturing hybrids might flower earlier. This is data that is probably collected in breeding trials by life science companies or publicly funded breeding programs. They look at flowering timing, flowering duration, and maybe even within flowering, once 20, 30, 40, etc. But once further down the road, I'm not sure if this data is available.
Okay, one more quick one for you, Nate, and then I got one for Paul. So Carol's asking about flower size. And so do you know if we've seen anything on a correlation between flower size and yield?
Yeah, so which part of the flower is getting bigger? Can I answer a question with a question? A flower has pollen on the stigma, and that goes down, pollen on the anther, and it goes onto the stigma. They talk, they communicate, and then reproduction happens. And if one of these gets bigger, or maybe both get bigger, does this increase yield further down the road? I don't know. To be quite honest, Carol, you've added some reading to my reading list.
Okay, this is a good question for Paul. And Nate, you can jump in, but we'll go to Paul first. So Manasseh asks, what might have led to the better than expected yields in Manitoba, considering how dry and hot it was?
Yeah, that is a tough question. I think that what we've seen even the last few years, we've gone through a more or less kind of a drier stretch for many areas, especially in Manitoba. But Manitoba does have some heavier soils, and it does have some groundwater systems that I think in some cases will benefit the crops, and perhaps more so than we're really accounting for in some of our yield and moisture model type research. So that's the only thing I could really pull out there, because boy, with that kind of heat and that sort of impact it has on flowering and days in flower and that kind of thing, boy, there really wasn't a lot very beneficial. So it's a tough one to call. Possibly the moisture wasn't quite as bad as the lack of rainfall would indicate if there's another source, like a subsurface source of water in some areas.
Nate, would you add to that? Anything to add?
Just that, precipitation can be so spotty. And I think that we saw a lot of that in 2021. For example, I live just south of Carman, Manitoba, and the quarter that I live on was canola this year, and it went just low 40s. And so, the farmers were happy with that. I think it was 7 or 8 miles east of my place, there were fields there that were averaging below 10. So not that far away. Heat temperature was probably very similar, in an 8-mile, 7-mile distance, but where I live, there's just a little bit more rain, and rain makes grain.
Any other notable observations between those two sites that sprung to mind for you?
Uniformity. That was also because of the rain, and this rain, this was the beginning of June 9th, I think, was when this event went through. So it affected the duration. It affected the rest of the growing season.
Yeah. Hey Keith, how was your yield based on what you thought it might have been, given the heat and the dry?
I mean, it varied from one end of our farm to the other. We had one part of our farm, like up by Maidstone, that ended up getting 8/10 of rain one week, whereas down by Lone Rock at home we had 2/10, and that was 10 bushels the acre difference. And so down at Lone Rock we were sitting at about a half a crop, and up at Maidstone probably a 75% crop. So yeah, if you got a little bit of rain right in that heat spot, or just after that crop could recover, it made a huge difference.
I want to get into some of these facts. I know, so Nate, you made the point quite clearly that environment is the big one. So genetics are all good. Farm management in general is good. It's environment. But I'm gonna give me a sec because I want to say one more thing from the chat. But I do want you to think about answering a question on how do we weatherproof canola. So how do we manage better around some of these big environmental issues? But before that, so we got a chat from John. So this is John just saying his list checklist when he's choosing a variety. Club root tolerance is first. John is in Alberta, but we want everyone to think about club root tolerance. Second is herbicide system. So Keith that puts that first. John puts that second. Third is maturity. So again, Keith, you mentioned that as well. Harvest management is fourth, and yield is fifth. Again, all of the canola varieties yield pretty well. There are some that stand out some years, but if you want to manage risk, it's some of these other factors. And then, of course, there's disease management and disease tolerance and resistance in there as well. Okay, Nate. So I gave you 30 seconds to think about an answer. What are you going to say?
Right. So similarly to, developing varieties that are resistant to clubroot or blackleg, we are doing this for climate-related things as well: drought, heat, even increasing nutrient use efficiency in canola and in other crops too. But there's like Dr. Sally Vale at Saskatoon. She's looking at drought tolerance. Dr. Malcolm Morrison at Ottawa's looked at drought tolerance and heat blast before. Dr. Rob Duncan at the University of Manitoba, Chad Kaselny, Pioneer. Everybody's doing this. So it's very similar to selecting for blackleg resistance, clubroot resistance. We're selecting for stomatal conductance and mesophyll conductance and things like that that will regulate water, or maybe there's a more waxy surface, and this will help with light penetration and things like that. You're muted, Jay.
Thanks. Thanks, Nate. It was bound to happen. Keith, I saw you light up. Did you want to jump in there?
Yeah, I would. I lit up because I'd forgot to mute myself. But I did want to go back to John's comment, John Mako's comment about clubroot. In our area, yeah, to me, that's a number one. And I forgot to mention that. I mean, we don't have the amount of clubroot in our area that they would, up in Vegreville where John farms or in that Edmonton area. But it is a risk, and it's a risk that we can't afford to take. So that's number one of my priority for choosing a variety too.
Okay, we're going to talk about emergence. And Nate, this. Well, all three of you know this. Data shows that seeding the beginning of May tends to yield more than the end of May. But over the past couple of years, we're starting to wonder if maybe waiting for the soils to emerge or warm up a little bit so we get faster emergence might be another factor. But there's so much that goes into early seeding. But here's the question from Orest. Why, when germination for top seed is well over 90%, why do we only get 60% emergence? So what's going on, and how do we manage for better emergence? Nate, do you want to start with this?
Sure. I don't think I have an answer. It's a really, really good question. It's like $1 million question. There's so many different things that drive the rate of emergence, soil temperature, soil moisture, the residue, the preceding crop, whatever was grown there last year, row spacing, the spacing between seeds, plant densities, your openers. Is it planted? Is it seeded? Is it broadcast? Is it broadcast by plane? Like, there's so much, right? And I would encourage, so I don't have an answer, and it's going to be different for every farm across the prairies. The way to move forward is to start counting plants in the spring, and maybe try out a couple different things. Use a hoop. We have a good tool. The Canola Council has a good Canola Counts tool that can be found on our website. We came up with a map, a prairie-wide map this fall, showing the percent emergence across the prairies, and we want to do this moving forward as well. So I think it starts with really good diligent record keeping, and then you evaluate your management practices or whatever it was that you've kind of changed or altered or tweaked, optimized, hopefully, with the results, and then we move forward.
Okay, Paul, I've got a question for you. And I'm so glad this question came in because we've got a weather specialist here. And so we just have to take a couple minutes to talk about what's going to happen in 2022. So do you have any idea what the weather probabilities are heading into 2022?
No, not really. And I'm long enough in the tooth trying to deal with this to know better. You can try and take a stab at it. There's some things that we can know, like Les Henry's soil moisture map. That's 100%. You know that. There's no question about it. But honestly, we could, if you're somewhere in Western Saskatchewan, you're saying, "Wow, it's really dry." Well, that can change. That can literally change in a day. And so, what do I know for sure? Not anything for sure, but what seems to be happening, and there is physical reasons why it may be in our weather system is the variability, and the fact that we're seeing a lazier jet stream with very deep wavy patterns that are persistent. So if it gets dry over a region on a synoptic scale, it's likely to sit there for a while, which is not good. And the flip side is that if you happen to be on the other side of that jet position and you're getting wet, you're probably going to continue to get wet. And then when it shifts around, it goes to the other extreme. So the Western Canada sits right in the path of the mid-latitude westerly airflow on the planet. And that airflow is becoming more lazy and meandering, and it's causing more variability. And so, that it's hard enough to predict at the best of times, but I think it's going to become even more variable and more unpredictable. That's my prognostication.
Keith or Nate, either of you want to jump in on that one?
Oh, I can't predict the weather. If I could predict the weather, I'd probably be retired by now. I'm the youngest one here.
So, Paul, I have a follow-up question for you. And it was you showed that vegetation index map from StatCan.
Yeah.
So this is more of an in-season situation map. This is where we're at to date. But do you see a way where farmers could use that for decision making?
On a farm scale, probably not. That map is designed for broad area coverage. It uses the NOAA and the MODIS satellites that are fairly coarse resolution. So they lend themselves to that. And what they do is they provide, even if it was higher resolution, it's a snapshot of where the vegetation is right at the current point in time. Now, my experience in this area is that one picture is nice, but not very useful. What's really helpful is to see how that vegetation develops over the growing season, because that can tell you a lot more than just one picture at one point. So it can be used if you wanted to, but there's a lot of work involved, and you have to have high enough resolution to see what's going on in your own local area, which you can't get with all satellites. Maybe we're going to do it with drones and things instead. I don't know, but you need a picture over the growing season. You've got to start following it sometime from when you start to get good vegetative growth up to the peak, and be able to do things very similar to what Nate was talking about. How long does it stay in these stages? This is what it could possibly help you with, but it does require some effort to get it.
Well, you three, we're at 12:58, so we have about a minute left. And I do want to get a last word from each of you. A key message, maybe one more question, Nate. So perhaps we'll go in order of presentation. So Paul, right back to you. What would be your closing soundbite?
Well, I mean, I think there's been a lot of things acknowledged here that we know. You can't control weather. You have control over what you select. And what Nate said, I think, really brings it home. Where you put your boots on the ground, what works for you there is not necessarily going to be the same as your neighbor just a few miles away. And becoming more cognizant of those risks, trying things and doing things on farm, I think needs to become more prevalent in what we do to try to make use of this information to make our decisions more distributed for the location and better informed. That's the best that we can do.
Thanks, Paul. Nate?
Yeah, just, record keeping, I think, is just, it's so important. And we think that we can remember everything. Like, how often have you said, oh yeah, I'll remember that, for no, we never do, right? So yeah, just write it down, right? Like I gave up trying to remember things for later. I have a notepad on my bedside table, I write everything down. And then going back and evaluating these records, and this takes time. It's a lot of work to go back and to sift through it all and to try to find out maybe where there's room for improvement. And I can empathize with that.
Keith, last word to you. You're on mute.
Thank you. I would say to do what's right for your farm, and what's right for your farm isn't the what's right for the neighbor's farming. We all have that different risk tolerance. We have that different equipment I talked about before. So find what works for your farm under your situation and your management conditions that you are in your risk tolerance, and just go with that.
Well, thanks, you three. We'll bring up that CCA code for CCAs who want to get a credit for this. I'll just note that the next webinar is Monday, December 13th, and the topic is maximizing hybrid potential, targeting traits to improve yield and consistency. I think registration is open for that. If not, it will be right away. And you can find details on that at your Provincial Canola Association website, or go to canolacouncil.org. And in the events section under About Us, you'll find a link to all of these webinars and the dates for all of the rest of them. Anyway, thanks again to Paul, Keith, and Nate. And also thanks to Cass Cardy and Justine Cornelson for their behind the scenes work. And of course, thank you to the host organizations, Canola Council of Canada, Manitoba Canola Growers, SaskCanola, and Alberta Canola. I'm Jay Wetter. See you next time.
Thanks, Jay. Bye.